कहीं मत कर दो।
रुको नहीं छोड़ो।
Good morning, all of you. Good morning, all of you.
Good morning, sir.
What was the last thing we covered in the previous class?
Capacitors in series and parallel.
Okay. Capacitors in series and parallel. Circuital analysis mein we should go to the second stage called Wheatstone bridge. Am I right?
Yes, sir.
Yes, sir.
Now, incidentally, the proof of Wheatstone bridge is generally given with resistors because that's what is prescribed. For you also in your HSC board everywhere, Wheatstone bridge starts with resistors, but it can be equally used for capacitors. Wheatstone bridge. Now, what is a Wheatstone bridge? It is something like this. You will have a galvanometer here. Galvanometer is a sensitive ammeter. You have this as resistance R1, this is resistance R2, this is resistance R3 and R4. When I close this switch, there will be current type coming into this branch and current type coming back into the battery. Do you all agree with that?
Yes, sir.
Yes, sir.
You assume small I current going into this branch, and what will be the current in this? Capital I minus small I.
Yes, sir.
Now, what are you in search of? We are in search of balancing condition. Balancing condition. What do you mean by the balancing condition of Wheatstone bridge? Current in this branch should be zero. Current through the branch with the galvanometer should be zero. That implies P and Q are at same potential. That implies P and Q are at same potential. When will there be no current flowing through it? When P and Q are at same potential. Now, apply Kirchhoff's law, by the way. This small I whole of that goes into this branch. This is capital I minus small I. This small I goes into this branch. This capital I minus small I comes into this branch. You are going in clockwise direction. Right? You are going in clockwise direction. Opposite to the direction of current, I minus I into R2. In the direction of current, I into R1, sum total will be zero as there is no current in this branch. You are finding out the condition for no current in the branch with the galvanometer. No current in the branch with the galvanometer.
So P and Q at same potential is defined by a Wheatstone bridge.
P and Q, if there is no current, that happens only if P and Q are at the same potential.
So that's a property of Wheatstone bridge that there will be no current.
Obviously, no, yaar, wahi to likha hua hai. IG is zero, is finding out the balancing condition of Wheatstone bridge.
Okay,
So
sir.
when will that happen? When P and Q are at same potential.
potential.
Now apply KVL to this branch. Opposite to the direction of current, I minus I into R. IG is zero. In the direction of current, I into R3 is zero. This is my
R4.
first equation.
R4.
R4. Hey, this is R4. That means this is R4. This is R3. R1, R2, R3, R4. I minus I into R4. Opposite to the direction of current, plus I into R. Right? In the direction of current, I into R. Now bring this to the right. Capital I minus I into R2 is I into R. Similarly, capital I minus I into R4 is I into R3. Divide both the equations. R1 by R2 is equal to R3 by R4 is the condition that you are in search of. R1 by R2 is equal to R3 by R4. You get IG is equal to 0. There will be no current in this branch. And when do you think that there is no current in this branch? When this point and this point are at same potential. A standard derivation there in your syllabus right from HSC till G. Generally, the standard is done with resistors. It is equally applicable for capacitors. How do we apply this to circuits? We shall understand this. Take it down.
Answer.
So
So 1 second, sir.
Answer.
Can I rub the board?
Yes, sir.
Right? This is the actual Wheatstone bridge. This concept is used in capacitor. This concept is used in heat transfer. This concept is used in fluid dynamics. All these are byproducts of this actual Wheatstone bridge. Different ways of looking at Wheatstone bridge. Purpose of a Wheatstone bridge. Have a look at this. They want the equivalent resistance of this. This is 2 ohms, this is 4 ohms, this is 1 ohm, this is 2 ohms. You want the equivalent resistance across AB. Now here I cannot recognize which of them are in series, which of them are in parallel. But if you apply the Wheatstone bridge condition, you can see that 2 by 4 is equal to 1 by 2. 2 by 4 is equal to 1 by 2. So there will be no current in this branch. So there will be no current in this branch. Right? If there is no current in this branch, you can remove this branch. How did you conclude there is no current in this branch? The balancing condition of the Wheatstone bridge is met. This by this is equal to this by this. Now 2 and 1 are in series. Equivalent resistance is 3 ohms. 4 and 2 are in series. Equivalent resistance is 6 ohms. 3 and 6 are in parallel. 1 by R equivalent is 1 by 3 plus 1 by 6 is 1 by 2. R equivalent is 2 ohms. A simple straight hit Wheatstone bridge condition. What if you have given me capacitors this way? No big deal, something very elementary. I take the same numbers, 2 microfarads, 4 microfarads, 1 microfarad, 2 microfarad, and I'll call this 5 microfarads. Find the C equivalent across AB. Take this down till here and find the C equivalent. Don't tell me answer is the same. It will not be the same.
Done, sir.
Done, sir.
Done.
Done, sir.
One second. Now here this capacitor is removed. 2 and 1 are in series. What is the equivalent capacity?
2 by 3.
2 by 3 microfarads. 4 and 2 are in series. Equivalent capacity.
4 by 3.
4/3.
That's coming same by chance.
Add both of them. 2 by 3 plus 4 by 3. 6 by 3 is 2 microfarads. Is a mere coincidence of numbers. Now, deceptive looking Wheatstone bridges. I am intentionally taking the same numbers so that you can recognize them easily. You want the equivalent resistance across AB, right? Now rearrange this format. Whenever you see hereafter, you should be able to recognize that it is a Wheatstone bridge. Rearrange this and show me that. I will take C and D here. I will take A and B here. A and C has a 2 ohm resistance. A and C has a 2 ohm resistance. A and D has a 4 ohm resistance. A and D has a 4 ohm resistance. D and B has a 2 ohm resistance. C and B has a 1 ohm resistance. A and C, A and C, A and D, A and D, CD is a 1 ohm resistance. C and B is a 1 ohm resistance. D and B is a 2 ohm resistance. You know what next? A
Yes, sir.
standard deceptive looking Wheatstone bridge.
Done, sir.
Once again, a deceptive looking Wheatstone bridge. Catch hold of point A, bring it out of the board and place it on the board. Point B, I pull it to the other side. This remains R3, this remains R. Point A, pull it out of the board and place it on the board. This will be R1, this will be R2, and this is point A. Point A, pull it out of the board and place it on the board. R1 by R2 is R3 by R. R1 by R2 is equal to R3 by R4. This branch will become null and void. A Wheatstone bridge, deceptive looking Wheatstone bridge. Find the equivalent resistance across AB. Find the equivalent resistance across AB.
So 200 ohm.
Right.
Yes, sir.
Yes, sir.
Yes, sir.
400 and 400 in parallel will give you 200 here. This is 100, 200, 100, 400. Now 100 by 200, 200 by 400, this we have already seen. It will come out to be 100 here, 200 here, 200 here, and 400 here. This branch in between can be removed as this by this is equal to this by this. So these both are in series, these both are in series, they both are in parallel combination. Find the equivalent capacitance across AB. Find the equivalent capacitance across area. Now listen, I'll make
That's
changes.
Sir, 1 second.
so
Correctly
9.
answer 9.
Yes, sir,
9
9.
is the correct answer.
Sir, please wait.
Yes, sir.
Now I'll make changes here itself. Have a look at it. 17 and 13 are in parallel. Do you agree with that?
Yes, sir.
Because these two ends are connected, these two ends are connected. 17 and 13 are in parallel. This will become 30 microfarads. 1 and 1 are in parallel. This will become 2 microfarads. Now we don't need designs here. Let us make it straight. 5 microfarads, we don't need a design. Let's make it straight. 30 by 6 is equal to 10 by 2. The 5 microfarad capacitor is null and void. 30 and 10 are in series. 6 and 2 are in series. They both are in parallel. Equivalent capacitance is 9 microfarads. all capacitance are C. Find the equivalent capacitance across AB. Are you people trying?
So 2
Yes, sir.
minutes.
Yes, sir. Yes, sir. So 2C.
To see, I think is correct.
Yes, sir, 2C.
I'll make 3 changes in the circuit. I'll pick up this point and place it here. Am I permitted to do that? The changes that I'm making in red. This point I placed it here. There's no component in between. These 4 points will be equipotential. So I can make the change.
Yes, sir.
This B I will place it here. This B I bought it here. Am I permitted to bring it here? Yes. Right? First change, I slightly changed the shape, which is insignificant. B, I bought it here, which is very much significant. Now observe the change I will make with this capacitor. These both points can be placed here, right? These both points can be placed here because there is no component here and no component here. This point and this point are at the same potential. So this capacitor, I will connect it this way. In between these two, I placed it here because this point and this point are equipotential. This point and this point are equipotential. Beauty lies in the eyes of the beholder.
Yes, sir, true.
C by C is equal to C by C. This branch is a galvanometer branch. Remove that. C and C are in series. C and C are in series. 2C, 2C and C are in parallel.
Sir, how are you permitted to move B there?
B from here. This point, whole of this line is equipotential. There is no component in between. Whole of this line is equipotential. I can keep B here. It is more like telling you, I have two capacitors here. I place B here or here or here, makes no difference, right? So from here I moved it to B. So these two will be C by 2, these two will be C by 2, and this is C. All in parallel will be 2C.
Sir, I did it in a bit different way. I end up eliminating another component.
There is no other way for this. This is the only way.
So can you just have a look at it once?
There is no other way. हो ही नहीं सकता. A and B are at the two input and output. You cannot remove any other capacitor other than this. This is the only one. Option है ही नहीं. Because when this is the input, this is the output, this is the only branch which will be equipotential, this point and this point. You removed which capacitor, you tell me, I'll tell you what.
The middle one. The lower middle one.
This one.
Yes, sir.
हो ही नहीं सकता. These both points are not equipotential. Stretch it out and see, bring it out and see.
So I thought that the C in the above it in the left and the lower C which you connected externally, they both are in one parallel, and then the circle C and other C are also in
What
parallel.
you have done is you have taken this C here and this
Yes,
C
sir.
here. You thought, but ये बीच फ्रॉम ब्रिज है ही नहीं. देख लो एक बार. A टर्मिनल अगर यहाँ पर भी रख दिया आपने, तो this by this is equal to this by what? For you to remove this.
So there's one more C over there, na, above the red one.
Your point is you want to keep this C here.
Yes, sir.
ये बीच फ्रॉम ब्रिज है ही नहीं है यार. ये कहाँ से बीच फ्रॉम ब्रिज बन गया आपके लिए?
Okay, sir. Understood.
Right, this point, this by this is equal to this by this. This is not the connecting point in between them. It should come between these two. This by this जब कर रहे हो, this terminal should come here.
Got it, sir.
There is no other alternative for this. This is the only way.
One minute.
सर फाइनल आंसर क्या है?
2C.
ओके
Done, sir.
Now this is the second stage of the analysis. First was series parallel. If I cannot see series parallel, I'll search for a Wheatstone bridge. What if Wheatstone bridge is also not visible? Then search for symmetry conditions. Symmetry is something that should strike to you at that particular instant. It is not a standard rule. You can look at it in so many ways. It is not a standard rule. You can look at it in so many ways. First of all, let us understand what we mean by symmetry. There are two branches identical. This is R, and R. Both the branches are symmetric. Can I claim that both the branches will have the same current in both of them?
Yes.
Yes, sir.
Yes, sir.
This you didn't apply Kirchhoff's law, you didn't apply Wheatstone bridge, you just looked at it by symmetry and you told me that. And why could you tell me that? Because
Resistance is same.
they are identical above and below. Then you will claim that this point and this point are equipotential, this point and this point are equipotential. Technically, what is the science behind that? If this is at potential V, minus IR will be the potential here, minus IR will be the potential. So after crossing one resistance each, potential will be the same.
Yes.
After crossing two resistances each, potential will be the same.
Yes.
After crossing three resistances each, potential will be the same.
Yes.
Some old textbooks prefer to say that all points which fall on the perpendicular line of symmetry, perpendicular to what direction of current? All points which fall on the perpendicular line of symmetry in a symmetric circuit are equipotential. Some old textbooks prefer to say all points which fall on the perpendicular line of symmetry, all points which fall on the perpendicular line of symmetry, perpendicular to what? To the direction of current, are equipotential. So if they're equipotential, what do you want me to do? If I had a resistance here, I'll remove it. It's equipotential, there will be no current. If these 2 points are equipotential, you can either join them, you can connect them both. You can do so many things with 2 equipotential points. If I have a resistance here, remove it, it is of no use. If I don't have a resistance, keep them as it is, I have no problem. I will connect these both points here, they're equipotential. You are welcome, you will get the same answer. Have a look at this. In this circuit, 3R and 3R are in parallel. 3R and 3R are in parallel. 1 by R equivalent is 2 by 3R. R equivalent is 3R by. It's what was the straight hit. 3R are in 3R are in series. R are in series. 3R and 3R are in parallel. No big deal. But suppose you recognize that this point and this point are equipotential and you want to connect them. I am okay even if you connect them. You connected these both, you connected these both. This is R and R, R and R, R and R. Can I claim R and R are in parallel? R by 2.
Yes, sir.
Can I claim these both are in parallel? R by 2. These both are in parallel. R by 2. Equivalent resistance is 3R by 2. So symmetry is all about recognizing equipotential points. Once I recognize, means of simplification can be more than one. But you will have to recognize. And the fundamental principle of recognition is two identical branches. After crossing one resistance each, the 2 points are equipotential. After crossing two resistances each, the 2 points are equipotential. After crossing n identical resistances, the 2 points will be equipotential. This is the bottom line. Let us take one complicated circuit and explain all the procedures of symmetry for that. And those procedures are not optional. Don't be under the impression that you can learn one and skip the other. Right? All procedures are required. Take it down to here first.
Done, sir. Done, sir.
Okay. Instead of resistances, I have capacitances. It is no big deal for you, right? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Hence, we are running two chapters simultaneously, capacitors and resistors.
Sir, capacitors and resistors are part of current electricity.
No, capacitors is a separate chapter. This subtopic comes in both. Same question with resistors, they'll give you. Same question with capacitors, they'll give you. All resistances are identical. All resistances are identical. Name them 1, 2, 3, 4, 5, 6, 7, 8, 0. I want the equivalent resistance. First rule of symmetry. Recognize the equipotential points. What do you mean by recognize the equipotential points? You told me all points which come on the perpendicular line of symmetry are equipotential. Perpendicular to what? Direction of current. Current is coming this way. So 2 and 8 will be equipotential. 3, 0, 7 are equipotential. 4 and 6 are equipotential. There is another way of looking at it. If current I comes in, it should split equally into both the branches and add up to give back 2I or I, right? When these both branches are identical, equal current will go into both the branches. Do you agree with that?
Yes, sir.
After crossing one resistance each, both the points will be equipotential.
Yes, sir.
After crossing two resistances each, both the points are equipotential. So two resistances from here, 1, 2, or 1, 2, or 1, 2, or 1, 2. So all points which are at a distance of two resistances from 1 will be equipotential.
Yes, sir.
All points which are at a distance of two resistances from 1 are equipotential. Same applies for 4 and 6. Now, once I know this, first procedure that we would suggest, 2 and 8, you told me are equipotential, right?
Yes.
2 and 8 are equipotential. Join them. ऐसा कैसे join कर लोगे यार? Have a look. This is 1, 2, 8, 3, 0, 7, 4, 6, and 5.
3R/2.
Yes, sir.
Right? Have a look. 2 and 8 are equipotential. I kept at 1 point. 3, 0, 7 are equipotential. I kept at 1 point. 4 and 6 are equipotential. I kept at 1 point. Now 1 is connected to 2. 1 is connected to 8. 2 is connected to 3. 2 is connected to 0. 2 is connected to 3. 2 is connected to 0. 8 is connected to 0. 8 is connected to 7. Now 3 is connected to 4. 3 is connected to 4, 0 connected to 4, 0 connected to 4, 0 connected to 6, 0 connected to 6, 7 is connected to 6, 7 is connected to 6, 4 and 5, 4 and 6 connected to 5, R by 2, R by 4, R by 4, R by 2 is 3R by 2 is the R equivalent across AB. So far, so good. First procedure of symmetry, is it clear to all?
Yes, sir.
Take it down, we'll deal with the second procedure of symmetry.
Done, sir.
1 minute, sir. Done, sir.
Can I rub the board?
Yes, sir.
Yes, sir.
Second rule of symmetry and a lesser used rule of symmetry. Second rule of symmetry and a lesser used rule of symmetry. Fold the circuit along the line of the current, along this. Why are you permitted to fold? Because when I fold, observe that 7 will come over 3, 8 will come over 2, and I am permitted to join them both because they are equipotential. Fold the circuit along the direction of current. Fold this circuit along the direction of current. It is a very less used rule of symmetry, but it works in some situations. But remember, don't blindly fold. When you fold, make sure that 8 is coming over 2 because they both are equipotential. Join 2 points only if they are equipotential. Right? When I fold this circuit along this, I will redraw the circuit here. Observe that lower part of the circuit is gone. This is B, this is A. 8 and 2 come here, right? 8, 2, 3, 7, 4, 6, 0. Do you agree with this?
Yes, sir.
When 8 comes over to this resistance, both of them are in parallel. This becomes R by 2. This will come parallel to this. You have connected 8 and 2. This becomes R by 2. Now this comes parallel to this. R by 2. This comes parallel to this. R by 2, R by 2, R by 2. See if you are getting the same answer. R by 2 and R by 2 are in series. R and R are in parallel. Right? R and R are in parallel means R by 2. R by 2, R by 2, R by 2 are in series. R
3R by 2.
is 3R by 2. And another way of looking at the same problem. Folding the circuit is something which I generally don't suggest because you cannot fold it blindly. You have to verify that 8 and 2 are equipotential, 7 and 3 are equipotential, 4 and 6 are equipotential before connecting both of them. Now, third procedure is one of the most used rule of symmetry. Third procedure is one of the most used rule of symmetry. Observe this carefully. If 2I current is entering here, I should have 2I current going out. Yes or no?
Yes, sir.
Yes, sir.
Out of 2I, I will have I and I here by symmetry because the above branch and lower branch is identical.
Yes, sir.
थोड़ा ध्यान से सुनिए. I should get back I and I here so that I get I here.
Yes, sir.
Some students may feel, why should you get back I and I here? I will have 1.5 I here and 0.5 I here. I will get 2I. The problem is resistances are identical. You cannot have 1.5 I there and 0.5 I here. Because when you apply Kirchhoff's law through this path and through this path, you should get the same. You apply KVL along this path and apply KVL along this path. You should get the same. Now, if resistances are the same, currents must be the same. So I should get back I and I here for two reasons. One, I should get 2I here. Second reason, when I apply KVL along this path and along this path, I should get the same value. Once I am taking resistance, the same current must be the same. Only then I will get same VAB. This changes the scope of the problem. Observe this. Capital I comes here and capital I should go here. So whatever current splits into these both branches must add up here.
I by 2.
Yes.
This current may split, but it has no choice. Whole of the current comes here. This current, even if it has got choice, will not avail it. It will come into this branch to give back I amount of current. I repeat the logic right from the start. Listen carefully. 2I current comes here, 2I should go. The circuit is symmetric above and below. So I will have I and I split into both these branches. I should get back I and I to get back 2I. Why I and I? Because the above branch and below branch are identical. I should get back I and I. Just as you split equal currents because the above two branches are identical, even the below two branches are identical. Now, whatever current splits here must add up here, only then I will get I current. This branch of current has no choice, it will come into this. This branch of current, even if it has got choice, cannot avail it, it will go into this branch. You disconnect this point because you know the same current goes into this particular branch. Problem is solved. R and R are in series. What is the equivalent resistance?
2R.
2R and 2R are in parallel. What is the
R.
equivalent resistance?
R.
R and R are in series.
3R.
The
3R.
equivalent resistance. 3R and 3R are in
3R
parallel.
by 2.
3R by 2.
Resistance. Whole of the game lies in recognizing the fact that you have to disconnect here. Now, some students ask me, how are you so damn sure that it is this current only which comes here? Here also it is I by 2, here also I by 2. Maybe this I by 2 came here. I damn don't care till when the value is the same. I will split it and tell you it is the same value. By not splitting it, I am having I by 2 current here. By splitting it, also I will have I by 2 current here. So for me, both the circuits are equivalent. So I damn don't care which current came here. Till when it is the same value of the current, I can consider these both to be in series, thereby disconnecting this. Hence, R, 2R and 2R in parallel gives me R. R and R in series gives me 3R. 3R and 3R gives me 3R by 2. All three rules of symmetry you are supposed to know. No one procedure is optional. I'll take a similar example like this again and explain the third rule of symmetry. Take it down till here.
Done, sir.
Now, after the rules of symmetry, in your circuital analysis, what did you write?
KVL.
Kirchhoff's law. Don't you think Kirchhoff's law is more fundamental? Here it becomes a game of luck for me to see symmetry.
Yes.
Kirchhoff's law should be more fundamental. You should have put that ahead of symmetry, but you put it behind symmetry. There is a reason for it. Please observe this. This is A and B. How do you apply Kirchhoff's law? R equivalent is VAB divided by 2I. R equivalent is VAB divided by 2I. If you connect this to a battery, this is VAB. 2I is going here, 2I is coming here. VAB divided by 2I is R equivalent. Yes or no?
Yes, sir.
Yes, sir.
Now, if you can tell me VAB, my job is done. Tell me VAB, my job is done. For which I should know the current in any one of the branch. You go this way, you go this way, you go this way, you go this way. Any one of the branch you should know the current. Then I can apply KVL. Without knowing current, how will I apply KVL?
Yes.
Right? Now here it's easy. I current will split into I by 2 and I by 2 because they are identical branches. I by 2 and I by 2. Now look at the path I will go in. 1 to 2, 2 to 3, 3 to 4, 4 to 5. Will I get BAB?
Yes, sir.
BA. What is the potential drop across this? Minus
Minus
IR.
IR.
Potential drop across this? Minus IR by 2. Minus IR by 2. Minus IR is equal to VB.
Yes, sir.
VA minus VB is 3 IR. Right? My requirement is VAB divided by 2I. That means it is 3R by 2. Is this the answer that you are expecting for R equivalent?
Yes, sir.
Yes, sir.
Then why did you keep Kirchhoff's law behind? See, I got the current in these two branches because I disconnected this. If I couldn't disconnect this, making a guess with the current will be difficult. So once I have disconnected, why apply Kirchhoff's law? Directly series parallel, you are getting the answer. Once I disconnected this, why should I apply Kirchhoff's law? Directly I'll get the answer. Do you mean to say every problem I can solve using symmetry without using Kirchhoff's law? There will be an instance where Kirchhoff's law becomes unavoidable. We will come to even that, but probably in the next class. Here I can solve the problem using symmetry as well as Kirchhoff's law. But there will be an instance where Kirchhoff's law is the only way of solving.
So this is the fourth method of solving.
Right.
Done, sir.
Not all rules of symmetry will be applicable here. Among the three rules of symmetry, one will be the easiest and rather the most applicable. I expect you people to solve using one rule of symmetry, whichever clicks the best, and Kirchhoff's. One rule of symmetry, whichever clicks the best, and Kirchhoff's. Is that clear?
Sir,
I will
sir,
wait
I
for
got
you.
sir, I got disconnected. The last thing that you did was using the KVL, right?
Yeah,
After that,
yeah,
okay,
yeah.
fine.
I'll keep you people on mute. I'll give you 5 minutes for this. Using one rule of symmetry, right? And Kirchhoff's law. 4R by 5 is correct. I will take I current here, I current here, I not current here. Q. Above you took I, below you took I. Why are you taking I not current in the middle branch? Middle branch is not identical to the above and the lower branch. So I will get back I here, I not here, and I here. First point. Is this clear?
Yes, sir.
Above branch and lower branch are identical. The middle branch has only two resistors. It is not identical. So life becomes much simpler when you split the circuit here. Whatever current splits here should add up here. Only then I will get I. So this current will go straight, but this current will have to go back into its own circuit. Only then I will get back I current. Whatever current splits here should add up here. That means whatever current is coming in this branch, I should have the same value of current here. Only then I will get I current. Problem is finished from here. R and R are in series. 2R and R are in parallel. 2R by 3 plus 2R. 2R by 3 plus 2R is 8R by 3. 8R by 3, 8R by 3 and 2R are in parallel. 1 by R equivalent is 3 by 8R plus 1 by 2R plus 3 by 8R. Find out R equivalent. Now look at the beauty. When you want to apply KVL, do you people remember how we split current into two branches, parallel branches? Resistance in the opposite branch, 2R divided by sum of both the resistors into the incoming current. So I will have I by 3 here, 2I by 3 going in this branch. I by 3 here, I will get back I here. Yes or no?
Yes,
Yes,
sir.
sir.
application of KVL, we have to learn this. RAB will be equal to VAB divided by total incoming current. What is the total incoming current? 2I plus I naught. Total incoming current 2I plus I naught. That means you will have to apply Kirchhoff's law 2 times because they'll have to eliminate I as well as I naught. Start from here.
So it is
VA
2I by 3, right? In the lower branch. In that only where you wrote I by 3 in the diagram, it should be 2I by 3, right?
greater the resistance, lesser the current.
Right, sir, sorry.
VA minus IR minus 2IR by 3 minus IR is B. Right? VA minus IR minus 2IR by 3 minus IR is B. VAB is equal to 2IR plus 2IR by 3, 8IR by 3. Now my requirement is VAB divided by, I need the value of 2I. 2I is 3 VAB by 4R. Agree? I naught also I will have to eliminate. How do we eliminate I naught? Apply KVL to this branch. VA minus I naught R minus I naught R is equal to VB. VAB is 2I naught R. I naught is VAB by 2R. Substitute both and see if you are getting the answer or not.
Yes, sir. So could you repeat how you got the equation for 2I again?
You mean this?
No, sir. 2I is equal to 3VAB by 4R.
Simplification of this.
So from there only. Okay. I'm sorry, sir. Got it. Yes, sir. Got it.
So,
Ah,
so couldn't we use the folding method in this?
we can. The
Sir,
lower
can you,
control take it above.
sir, can you show that because I made some mistake in that?
Yes, sir. Me too.
Fold this above. So what will this be?
R by 2.
R by 2, R by 2, R by 2, R by 2, R by 2.
So what is this equivalent? R by 2 and R are in?
Series.
R by 2 and R by 2 are in series. This will be R. R and R are in?
Parallel.
R and R by 2 are in parallel. So how much are you getting this branch? You tell me. That is in parallel to 2R.
Okay, sir.
Done, sir. 1 minute, sir. Done, sir.
Using any one rule of symmetry, I want the equivalent resistance across AB. Using any one rule of symmetry, I want the equivalent resistance across AB. Now listen.
Sir, 1 minute.
Okay.
Done, sir.
Now listen, I will have I1 current here, I2 current here, I3 current here. Do you agree with that?
Yes, sir.
I should get back I1 current here, I2 current here, and here I have no choice. The same I3 should come here. Because it is symmetric about this line. If I keep a mirror here, left and right looks identical. If I keep a mirror
Yes.
here, left and right looks identical. And I should get back the same current which is entering here. I1 plus I2 plus I3 is entering. I1 plus I2 plus I3 is coming out. Right?
Yes, sir. We can disconnect that R above.
Now if whole of this I1 is coming into this branch gets disconnected and the problem is solved there. R and R are in series. I will redraw the circuit here for your convenience. R and R are in series. 2R and R are in parallel. 2R by 3 R should not be difficult for you hereafter. These three are in series. These both are in series. Those three branches are in parallel.
So,
हाँ,
so I had a doubt actually how you remove that R3.
इतना देर तक प्रॉब्लम सॉल्व किया आपने. Whatever current goes into this should come into this branch, right?
Yes, sir.
The branch निकाल दो, only then whole of the current goes into the branch. Clear or not?
Yes, sir.
Pyramid with a square base. Pyramid with a square base. Each is of resistance R. Each is of resistance R. Find the equivalent resistance across AB. Each is of resistance R. Find the equivalent resistance across AP. Pyramid with a square base. Anyway, what is the answer for that?
8R by 15.
8R by
15.
1.5.
Yes.
I'm getting R by 3.
Sir, 8R by 15.
1 by
8R by
R
15.
plus 1 by R plus 2R by 3 plus 2R will be 8R by 3. 3 by 8R. 8R. 4 plus 8 plus 3. 15 by 8R is 1 by R equivalent. R equivalent is 8R by 15. You are trying this problem or should I say?
Yes, I'm getting it.
Sir, is the answer R by 2?
No.
So 10R by 3.
I think no.
Sir, 8R by 15.
I have the answer.
Yes, sir. 8R by 15.
Yes, sir. 8R by 15.
8R by 15 is correct. Place your hand on the top of the pyramid and crush it. क्या करना है? Place your hand on the top of the pyramid and crush it. Top view will be like this. Say something. Yes or no?
Yes, sir.
I1, I2, I3. I should get back I2 here, I1 here, I3 has no choice. Whatever current splits here should add up here only, then I will get I1 current. Now you understand why you are getting 8R by 15 same
Yes,
answer?
sir.
Equivalent resistance across AB. All resistances are identical.
Three R by 5.
Yes.
3R by 5 is correct. Here the rule of symmetry
Sir,
used
1 minute. sir, you can start.
Here the rule of symmetry used is this branch and this branch are identical. This will be identical. Incoming current will split into these three branches. These both are identical branches. Do you agree with that?
Yes.
If these both are identical branches and equal current flows in, can I claim these both points are equipotential? Same current after crossing one resistance each will be equipotential. Yes or no?
Yes, sir.
Agreed?
Yes, sir.
After crossing two resistances each, again it will be equipotential.
Yes, sir.
3R and R are in parallel. This is 3R, this is 3R, this is R. R and R is 3R. R and R is 3R. 3R and R are in parallel. 1 by 3R, 1 by R plus 1 by 3R is 1 by R. How much are you getting the answer?
3R by 5.
Homework, HCV, first 25 exercise problems. First 25 exercise problems.
The capacitors.
Capacitors. 31 to 31 to 59. First 25 exercise problems. 31 to 59. Right? Complete this homework. After the next lecture, you will receive the first assignment sheet. Because in that first assignment sheet also I have given few on force on dielectric. Force on dielectric and yet to come. Right? When is our next lecture?
Sir, I think Thursday. I'm not sure.
Thursday, sir.
We have one more lecture this week, right?
Yes, sir, we have.
Fine. After the next lecture, you'll even receive the assignment sheet. Complete your homework by that.
Sir, you have any idea why 2 hour classes are being kept now? We are good with the portions, so then why?
No, quite a few batches are lagging behind. But then they cannot put 2 hours only for some batches and 1.5 hours only for some batches. Because faculty's timetable will get disturbed. Now, when faculty interchange, I take the first lecture in some batch. वहाँ 1.5 hour कर लूँगा. Second lecture 2 hours कर लूँगा. The third lecture के लिए half an hour late हो जाऊँगा. So some batches के लिए they want to push the syllabus ahead. So they have to make it 2 hours for every batch. Right?
Yes.
See you people in the next class.
Thank you, sir.
Good day.
Thank you, sir. Bye, sir.